graphing logarithms, we're going to start with the parent function like we do with any function. So if we remember, f of x equals log x, which now means log base 10 to us, which is important. That'll be important in the future too when we look at some points. Some distinctive features, if we remember, there's a vertical asymptote at x equals 0. So I go ahead and put my vertical asymptote in. I had 2 points, 1, 0, and 10, 1. These were important points in terms of graphing. It's a little small here, so it's hard to graph. We'll try to get a little graph right there to represent my parent graph. And if I remember correctly, the domain is 0 to infinity, and the range is negative infinity to infinity. There's the parent graph, log base 10, we know now, of x. Now the transformations are going to make a big difference to my graph. I'm going to move it left, right, up, down, stretch, shrink, all the stuff that we normally do. So let's look at what each of these things does. A is still going to do orientation. So if A is positive, I'm going to have a shape like that, like I normally do. If A is negative, I'm going to reflect it, so my shape's going to go more like that, just so I can keep in my mind what the shape should look like. The base is used to find 2 points. The 2 points I'm going to use to graph are from the base. And I'm going to use log properties, specifically log base b of 1 equals 0. That's going to be one of my log properties that I use. And secondly, log base b of b equals 1. That's going to be the other log property I use in order to get my points. Inside, we know that we always take opposite, so that's no different. We still take the opposite of c, and that is going to be to find the vertical asymptote. So if we want to find the vertical asymptote, we take the opposite of the c value. And lastly, the d value is the vertical, whoa, that shouldn't have happened. Let's get rid of that. The vertical transformation, or vertical shift. That was the way. Vertical shift up and down. But he doesn't really matter. He'll just get taken care of whenever we do our points. So let's look at a couple examples. First example. Back down. First example. Let's suppose that I have f of x equals 2 log base 3 of x minus 4 plus 1. The most important feature of a log graph is the vertical asymptote. So the first thing I'm going to do every single time is find the vertical asymptote. And we do that by taking the opposite of the c value. So in this case, it's going to be positive 4. So go ahead and put your vertical asymptote over here at positive 4. This one's a little off, but we'll just go with it. So there's my vertical asymptote. I know from the a value that my shape should be increasing like that. So now I need to find these 2 points. First point I want to find uses the fact that log base b, in this case 3, of 1 equals 0. So I ask myself, what value of x would get me a 1 inside? I look at it and that value would be 5. So I'm plugging in a 5. Once I put in a 5, I'm going to get 2 log base 3 of 1 plus 1, which becomes, well, log base 3 of 1 is 0, so that's all gone away. So it becomes a positive 1, which means I have the ordered pair 5, 1. So I'm going to go to 5, 1 and get my first dot. Secondly, I want log base b of b, which is log base 3 of 3, because I know that equals 1. So I think about what x value would get me that. Well, if I look here, and think what would give me a 3 inside. The x value has to be 7. So I plug it in, I get 2 times log base 3 of 3 plus 1. Well, we know that this is 1, so 2 times 1 is 2, plus 1 is 3. Or that represents 7 comma 3. So I go to 7 comma 3 and get myself an ordered pair. So in this case, I just go ahead and draw my logarithm graph. Second example, if I go ahead and erase these stray marks, my second example is going to be f of x equals negative log base 4 of x plus 1 minus 6. If I can get that written. There we go. So first thing, vertical asymptote. Vertical asymptote is the opposite of CD, so in this case it equals negative 1. So I'm going to go through and just put all my vertical asymptote dots at negative 1. Next thing, I think about my log properties. I want log base b of 1, so log base 4 of 1. The x value I need in order to make that happen is an x value of 0. So I go ahead and I plug in 0. That gives me negative log base 4 of 1 minus 6. I know all of that goes away, so I get 0 comma negative 6. So I go to 0, negative 6, and put my dot. Second, I want to do log base b of b. In this case, that would be log base 4 of 4. So I look inside and say, what would give me a 4 inside? That would mean an x value of 3. So I have negative log base 4 of 4 minus 6, which would be negative 1 minus 6, which is 3 comma negative 7. So I'm going to go to 3 comma negative 7, get myself a dot right there. It's not easy to do. And then I realize that my a value, this negative right there, means that the shape should come down and over, which is what fits with my graph. So if I am accurate enough on the small screen, there is a sketch of what my logarithm looks like if the pen would cooperate. So not a great sketch, but you get the idea. The key is to find your two nice points by using those two properties. If I scroll up right there, log base b of 1 is 0 and log base b of b is 1. Choose x values to make that happen.